So yes, I'm recording.
Perfect.
All right.
Thank you. Just in case we get into some really good discussion, this is good research for me as well, so I can understand a little bit more about what people are concerned about or interested in. So thank you again, everyone, for coming, because we're all here to help each other and work together. I'm going to go ahead and share my screen. All right. So Farmington River Watershed Association, like I said, that's where we're from. I'm from. We are dedicated to protecting, preserving, and restoring the Farmington River and its entire watershed, which is all of the land that drains into the Farmington River and its tributaries. We do a lot of this work in partnership with the Isaac Walton League of America. They have this program called Salt Watch. I will be ending this slide presentation on a bunch of QR codes and links, and that will be one of them. If anyone is interested in checking it out, you can also just type in saltwatch.org on your browser. It should come right up. I'm not in the proper presentation mode. That's okay. So first of all, as just a little bit of perspective, we use 20 million tons in the US every year. That does include Alaska as well. They don't have a whole lot of roads that they can use salt on because there's so much snow, but they're using it too. Hawaii, not so much probably. But we use a lot of it up here in the Northeast, as we know. They are very good for keeping us safe. We love salts because we can actually drive on our roads. We can walk on our sidewalks. The issue is salt dissolves in water. So that water, when snow melts or when it rains, is going to wash into our waterways. It's also going to soak into the soil a little bit, which is not good for a lot of the plants that live on soil or in freshwater ecosystems. They're just not used to the salt. Another issue is that it weakens our infrastructure, concrete, brick, stone, also steel. It corrodes steel. As we know, salt is corrosive. As far as into water, when it gets into our lakes, streams, and wetlands, it's bad for the fish, and it's not great for our water resources in general. Also, we have been finding out from our research at FRWA that it seems that it's getting into groundwater in our watershed as well, which makes sense. We've been using salts for decades. And the issue with a lot of these organisms, the fish, the plants that are harmed by this salt is that they can't use it. They can't metabolize it. So it travels into their bodies and it just stays there, and then they die, and then it just gets into the water, and then it stays there, and then it goes into the water next to the river and it stays there, and it just sticks around. One thing about chloride pollution is that it does have a far-reaching effect. 1 teaspoon, will pollute 5 gallons of water. When they use the term permanently in this infograph, I think maybe they're being a little dramatic. Eventually, a lot of chloride does make its way downriver, down to the Connecticut River, past Hartford, and into Long Island Sound, where salt isn't an issue. There's already salt there. But while it is in our freshwater resources, it can be problematic, especially because it is increasing in concentration as time goes by and we continue to use the salt. So, as I mentioned, it can contaminate groundwater and harm aquatic life. Road salt is one of the things that actually contributes to salt contamination in our water. Also softeners that we use and chemicals that we use in agriculture mostly also can produce some salt. But around here in the Northeast, it's really road salt in the wintertime that is the biggest input. As I mentioned, road salts aren't always great for plants that are on the roadside or near the road or in the stream near the road or the wetland near the road. This little graphic here shows cattails. We call it typhus. It's the Latin genus name, I believe. A lot of places think that cattails are bad, and there's another one that's good. It's called Phragmites because Phragmites can tolerate salt, and people kind of certain interests like to say that it's pulling the salt out of the water, and it is if you're coming and you're cutting the grass and hauling it away. But if you're not, it just goes right back into the system. So this cattail right here is unfortunately one of the plants that is not tolerant to salt, and it is replaced by more salt-tolerant plants over time. Another thing that this little picture shows is just that we don't have as much growth in aquatic animals. When there's no road salt, this guy grew a lot bigger in 25 days. And, these are important food for other fish and other animals that need them to grow big. And they're important parts of our ecosystem on their own as well, of course. One other thing is that not all animals can tolerate road salt very well. I mean, most of our, like the dog, the cat here, they're big. If the dog starts drinking from a puddle of salt, it'll probably have to drink a good amount before it throws up, and it'll have to drink a whole lot before it actually gets itself sick. But overall, pets can be harmed by it. Also, it can hurt their little feet. They make pet safe ones, pet safe salts. We can talk about that a little bit later. One other thing related to wildlife that I thought of recently that I have not included in this presentation yet, or related to animals, I'm sorry, is related to wildlife. We have some animals in the Northeast here, mostly deer, but also moose a little bit. And up north, we've got elk. All of those, like horses, they have hooves. They require salt in their diet. So it can actually attract them to the road because they smell it and they want to go and lick the salt, which, as we know, deer plus car is really bad news for everybody involved. We don't want them anywhere near our roads. We want them to be happy and healthy out in the woods. So that's one other thing to consider when we're looking at a big pile of salt like this heavily pixelated low res picture in my background is that it's attractive to our deer friends. One other issue is that in areas where people have well water, if that salt gets into the groundwater, it can come back up into the drinking wells. And some people, getting salt in their well, it makes it taste kind of weird. They don't really like it. You don't want to go and pour yourself a cup of salt water to drink. So that can be an issue, and it can cost people money. This photo here, this was taken in the Farmington River watershed in Simsbury under a bridge. And of course, eventually a bridge is going to rust, especially when there's water coming down. But when there is a lot of road salt being used, that corrosion is going to be accelerated. And on bridges, unfortunately, they tend to freeze first. So a lot of the time, more salt gets used on those. So now that we have a little background on salt, we can talk a little bit about how we can be smart when we're using it. One method that really gets pushed a lot with the Isaac Walton Salt Watch program, as well as with the Wisconsin Saltwise program. I believe New Hampshire and Minnesota also have some pretty good salt advocacy programs, but shovel, scatter, and sweep. The first one is that salt does not get rid of the snow. Throwing salt on snow, you'll see you just have these little tiny salt crystal sized boreholes that just go down into the snow and don't actually get rid of it. So shoveling the bulk and getting it out of the way is really helpful in reducing our salt use. Scatter is just pretty much being cognizant, being aware of how much salt we're putting down for the amount of space. It says here, a 12-ounce mug holds enough to treat a 20-foot driveway. That is a 20-foot single car driveway. I must point that out, but it pretty much shows in that picture here, you want those crystals to have space in between. And we'll talk a little bit more about the science behind that in a minute. Sweep is something that you can use, first of all, to reduce the salt getting into the water, and also to save you money and make you not have to go buy that giant bag of salt as often. When the storm is done, that salt is just going to sit there and not do anything and get kicked around into your lawn, kill your grass. So sweep it back up, you can reuse it for the next storm. It's kind of a recycling thing. This one's wordy. Okay, so this goes more into the shovel, scatter, and sweep thought processes, I guess. It says on the right here, the more snow you remove, the less salt you have to use. That's pretty self-explanatory. Scattering, I don't like this infographic. It's too many words. Switch. That's the reason it's up here, is that number 4 that is on this infographic. The rest of it says pretty much the same thing as we just talked about. Switching comes to, it makes more of a difference in places that get really, really cold, because road salt will work up to, I believe, -10 degrees Fahrenheit. Please don't quote me on that. to a certain, oh, it actually says 15 degrees. Okay, 15 degrees, not negative anything. I'm sorry, all of my bars are in the way of this right now, but you can use different de-icers if it does get really cold. That might work better, is what that switch part means here. On the left, just some tips that sometimes people don't quite realize. If you're walking on your icy sidewalk and you have salt on it and you don't feel it going crunch, 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 that is okay. More salt doesn't make it melt any faster. What actually happens with this salt is that it lowers the temperature, the freezing point temperature of the ice around it and the water around it. That's how it melts the ice. So it has to be in as much contact with the potential icy area as possible in order to work. You want space in between your crystals. Each salt crystal needs, kind of like when you're baking cookies, it needs a little bit of space to do its work. Otherwise, they're going to crowd each other out and it's not going to be as effective. Big piles actually are less effective than the scattering method when you're putting them out on a slightly icy or even before icy sidewalk. Even if it's cold and it's about to snow, you can still put your salt down then. Only thing is you just want to make sure it's not bouncing all over the place. We'll talk about that later too. Once again, 12-ounce mug for 10 sidewalk squares or a 20-foot single car driveway. If you look at the picture on the right, that's kind of what you want it to look like. You want each one to have a lot of space in between. And then you kind of want to go out later on and shuffle them around a little bit. Again, same concept, but this middle picture here, you can also see, I call it the white sheet of salt. You don't need all that. Again, that's been trampled and run over a lot. So the salt is just ground into smaller particles, but it's a lot. You don't need it. One thing that I notice a lot is that I think a lot of people think that the salt is supposed to be used for traction. And it can give you traction, but it's not very good at giving traction. If you really want to put something down that's not going to melt and you can just walk on the ice more easily near your house, then you would want to go for sand or a really, really fine gravel, but probably sand. So once again, I said that the freezing temperature of ice is actually lowered, which means that the ice has to be a lower temperature in order to freeze. That's how these salts melt the ice. What also happens is that it starts very, very slowly when salt is directly applied to ice or to frozen water. It takes a little while. Then once it really starts going and starts melting, it's like a snowball effect. That's a really bad analogy for talking about ice, but that's what happens. It goes faster and faster and faster. It's a rolling stone that's gathering tons of moss somehow. I don't know. My metaphors are not good today. But basically, the point is give it 10 minutes, 15 minutes to work. You want to put the salt down very early in the storm before you get a whole bunch of snow and ice forming. Then the salt will actually help to stop that ice from bonding with your pavement and with your concrete. So another way to approach smart salting, something that I've been doing at home, and you may have seen these white lines you can see on this, again, low resolution photo on a full screen, but those white lines in the road are something called anti-icing. It's a proactive way of controlling ice. It's done before the storm. And what happens is that they're actually spraying a salt water liquid, a brine is what it's called. They just mix salt with water, spray it down on the pavement. And what these lines are going to do is cause breaks in where the ice would be and make it melt in between to some extent in between these lines as it keeps moving, because the salt dissolves into the water and the water moves back towards the ice and kind of keeps moving in. So even though this road is not completely wet with this salt brine, those lines are still going to do a lot of really good work. The key is going really early in the storm or right before the storm. And this only works also in situations where the ground is kind of a consistently cold temperature where ice would form and there's not going to be rain in between. If you go, you say you put this down in the morning and then it warms up a little bit in the day and it rains, that's just going to wash away into the drains. But if it's 25 degrees and it's supposed to snow tonight, you know, and get a little cooler, then these will go there. Those lines with the salt in them are going to stay in place. And once that snow comes and the ice starts to form, they're going to be fighting it from the bottom up rather than from the top down. So once again, salt brine, essentially 23% is the tried and true research tested best percentage. At home, I grab a gallon, like a water jug. I fill it a quarter of the way with salt. Put some really hot water in there, shake it up a lot, poke some holes in the top, go out to the sidewalk and just spray it off. Spray the sidewalk down. It doesn't even need to be as wet as this guy is doing. He's got a really nice sprayer. He might, you know, work for a company that's doing this sidewalk, and that's great. But you don't even need that much. It doesn't have to be high tech. You can use a garden sprayer if you have one of those. All it is mixing a quarter salt, 3/4 water, spraying it down before the storm. It's really easy to do at home, which is part of why I love anti-icing. As I mentioned, it works from the bottom up, prevents the bonding of snow and ice, and it helps the ice at the surface of the road to just not form in the first place. So after that happens, because the ice hasn't formed right at that surface, it kind of just stays there. If the temperature stays cool enough and there's not rain in between, it'll just stay right where it was even after the road dries off, because the water will evaporate, the salt's going to stay, and it's going to be just very fine because it had been dissolved. So if you have a situation where there's going to be a weekend where it snows a little bit every day, or you have a storm and then 2 days off and then another storm, sometimes just treating your sidewalk once this way can work for both of those, which is really nice. If that salt has not had a chance to wash away, then it's going to work again the next time. And that is all I've got for our smart salting. We have links here to our website, to saltwatch.org, as well as Wisconsin Saltwise, which I mentioned before. And I guess we can go ahead to the chat and see if anybody has any questions. Let's see.
Nobody's put anything in the chat so far. Does anybody have any questions for Heather? You want to just come off mute?
Yeah, if anyone wants to pipe in.
Hi, this is Doris. How you doing today?
Hi, Doris. Good. How's it going?
Great. I want to go back to, you said the salt being applied is really not doing what we think is doing, is what you're saying.
The salt, it does melt the ice. It does that really, really well. It does a very good job because it lowers that freezing point and means that the ice at the temperature it is now going to be liquid. It's just a thing that salt does in water. But other than that, as far as if we're trying, if you're trying to use salt as, okay, for example, I have a really crappy sidewalk next to my house. Part of it is like blacktop paved, and it's part of it's just dirt, and it's all divoted and all uneven and a total mess. It's impossible to fully clean. So what I should actually consider doing, and now I feel like a heel for not having done it yet, the best thing to do, if you just want to, if you have a spot that you know is going to pretty much be icy no matter what, and if you can get it to not be icy, it's just going to be a nasty puddle, you can get dirt. Throw the dirt on top of the ice. That's going to give you the traction you want for the rest of the cold season, rather than you put a whole bunch of salt down for the traction, but then eventually it's going to melt. The dirt is going to give you that traction. Also, another thing that salt does not do that some people think it does, it's not going to get rid of your snow. It will fight the ice. Snow is almost too weak for it, but because there's so much snow, it just doesn't act the same way. There's too much air between the particles in snow because it's so much lighter than the ice. Yeah, but it does work really, really well for ice. That it definitely does. Also, one other way is if it's too cold. It only works to that 15 degrees. Below that, there are other types of salts that you can use. Some of them are magnesium chloride and potassium chloride. instead of sodium chloride, which is your basic salt that is on that big pallet at the gas station, you know, you can get those ones that are, and they advertise right on the bag for colder temperatures. There's also pet safe options. Those are, instead of chloride, those contain acetate, which is kind of similar to vinegar, and they hurt when you touch them. But either way, we shouldn't be touching those with our hands. We're supposed to scoop it. But supposedly those are better for pets to walk on if you're concerned about the sodium chloride hurting their paws, because it can, after a while, you know, if you have to put down a lot of salt and you got to take your dog out 5 times a day to go, then after a while it's going to hurt his little paw pads. So they do make these pet friendly versions that do not contain chloride, but it's not really known well whether or not they have effects on water or infrastructure or what they do once they are done fighting the salt. I like to think that those are a little better for the environment, but that's, I don't know any research behind it.
Okay, so great presentation. Thank you for the information. But what action items are you giving us for us to go and to our towns and our cities and to our agencies to let them know that you need to do something different because
Okay. So saltwatch.org that I still have up on the screen here. There is on that website. Yeah, thank you, Doris. That's awesome. That is, it has a what can you do tab on that website, and it brings you to this page of so many advocacy resources. They actually have template letters for legislators, all sorts of different things. There's flyers and posters, stuff like that. One other thing that will not mention is that UConn, University of Connecticut, has a training program called the T2 from the T2 Center of UConn. I cannot remember what the acronym stands for, technical training, something like that. And it is called Green Snow Pro, the Green Snow Pro workshop that they offer to municipalities, and they actually just expanded it a little bit. So now they have workshops that they offer to private contractors as well as people that mainly just do sidewalks and trails. And they have these trainings that they hold a few times a year, and they have a map. They have a map of which towns and municipalities have undergone this training. I don't think they have any information on private operators that's publicly available. I haven't tried to call them to ask, but yeah, it is the T2 Center at UConn. I'm going to put it in the chat. Aha, using technology for good.
There is a question in the chat too, Heather.
Oh, perfect. Saltwatch volunteer program. Oh, I did not go over the volunteer program. So yes, Isaac Walton Saltwatch program does have a citizen science component. It's really easy and it's really versatile, and it's something also that if you happen to know someone who really wants to do some sort of chloride study, like for school or something like that, please email me. I'm putting my email into the chat right now. Because we can help people develop research projects using this program. It's, again, so easy. So you go to saltwatch.org, you fill out their Saltwatch pledge that, you know, you're going to try and be salt smart. And they send you a free kit in the mail with 4 test strips. You go out to whatever stream you feel like, anywhere you want. You collect a water sample. They do ask that you rinse your vessel 3 times, so you have to dump it a couple times, which is great to do. But if you're, you know, throwing a bucket off the bridge, which you totally can do, and it's a lot of fun, you got to remember to rinse that bucket 3 times and then rinse your sample jar 3 times before you put your dipstick in. But it's these 3 little strips, or 4 little strips, I'm sorry. And each time you go out is that you take one of those strips, you put it in your little water sample. They give you a card that you compare what your strip looks like to, and it has a direct correlation to the amount of chloride that's in the sample you just took. They have an app that you can actually upload your data, and I'm pretty sure they still do it just as taking a picture. I'm not 100% on that. At FRWA, we do so much of it that we keep a spreadsheet because we also, you know, compare that data to other chloride data. So we submit that to them directly via email. You can do that as well. Let me see if I can link. I'm going to stop sharing my screen and peek really quick. And try and remember if they have a link here for if you want multiple kits, but actually easier than that, let's not take the time. If anybody wants to do this and wants multiple kits, email me and I'll make it happen. It's really, again, really easy. You can either, like, what have we done? We took one of those grabby sticks once and just duct taped a water bottle to it to reach down and grab samples, because you got to be careful in the winter. There might be ice on your stream, but also if you have like a bridge or a small culvert or something where you can stand on the edge of the road and throw a bucket over, that works really great too. It's something that's fun to do with kids. They give you the 4 kits hoping that you will go out to the same stream 4 times in the same year. But if you don't, nobody's going to yell at you. They will take all of the data. So you could go to 4 different streams on the same day if you want to. That's totally fine. You can do whatever you want with it. Receiving this recording. Yes, I will email this recording and a little, like, some links or some good resources to everybody. I'll make sure to do that. And does anyone else have any other questions?
Are you able to get everybody's email from the Zoom?
That's a good question.
If you
I'm
would
not
like
sure.
Heather to email everything to you, put your email address in the chat right now and I will save them all.
Perfect. Yes.
Just to make sure we have everybody if you want to
Thanks for
record
that.
them. But I think that, I mean, I'm so glad we recorded this, because I think this is such a good informational that we can, you know, have. Please email it to me. I'll send it to you too. So Sierra Club can have it to
Fantastic.
tell our people, to tell our folks.
Yeah. Oh, that's great. And now this presentation that I use is kind of something that I whipped up really quickly for a school to do an advocacy program, which is kind of why I had reiterated some things a lot of times with just one sentence and one graphic. So the feedback and these questions are going to help me to, next time I'm able to go back and update that presentation a little bit. Next time I can talk a little bit more about some things that people are concerned about, which is awesome. So thank you all so much for coming today. And I guess we've got some emails emails in the chat. If anybody else wants to throw their email in the chat, then you can do that now and I'll send it to you, or you can shoot me an email. Mine is right in there, hgeist@frwa.org. And I will get back to y'all as soon as I can. And I guess if no one has any more questions, I can give everyone 26 minutes back.
Thank you.
Thank you so much, Doris.
In the chat, I have Doris's, I have
Tom's.
Sashevhaus. I'm
Yes.
sure that's
I
and
do
then
have
I saved all 3
the
of them,
chat
so-
recording to my computer after this.
Oh,
so
perfect.
Yep.
Beautiful. All right, excellent.
So I'll have everyone's. All right. Well, thank you so much for taking some time out of your Wednesday. Is it Wednesday? I think so. Yeah. And be safe out there. Be smart. And we'll talk to you all soon, I guess. All right. Thanks, everybody.
Thank you, everyone.
Thank you, Anne.
Thank you, Heather. This is
Of
amazing.
course. Yeah. I mean, I would like to do this periodically. That'd be cool.
Yeah, it's
Yeah.
amazing.
Yeah,
Here,
we
I'll
can
stop this
chat.
recording.
It's always nice